Hi everyone, in this video we're going to see the solutions to the worksheet of the week 2. This is in trigonometric integrals and integration by parts. So first we have this integral here, x squared sine of 3x, and we're going to use integration by parts since this seems to be a multiplication of two functions, and that's the tendency that we get. Of course, the first thing is that we need to do a selection of who's going to be u and who's going to be db. Because we have this power here, we would like to reduce that power, and we're going to use u equals x squared, since the u then immediately is going to be 2x, and that will reduce the power in front. Now, if we do dv equals sine of 3x, then b, that is going to be integrated in this, it's going to be the integral of sine of 3x dx will be 1 over 3 sine, 1 over 3 cosine minus 1 over 3 cosine of 3x. Remember that the integral of sine is minus cosine, and because we have this 3 here, then the substitution is going to provide us with this 1 over third in the output. If you don't remember how to get to this point, make sure to check back the review on substitution. Now, when we use this formula, then we do u times b, and so it will be u times b. We will get minus x squared over 3 cosine of 3x, and then minus the integral of b du. And so again, we have here 1 over 3 cosine of 3x, and the du is going to be 2x, and so times 2x dx. We can, of course, simplify that. Let's put this in a box. We can simplify that, and this is going to be minus x squared over 3 cosine of 3x, and then the minus and minus is a plus, so you're going to have here 2/3 of x cosine of 3x dx. Now notice this is still going to be another integration by parts. We're gonna need to do the second integration by parts to solve this integral here, and the pattern is gonna be exactly the same. We're gonna have u equals x, and the dv now is going to be cosine of 3x. So the du is 1 dx, and the v is the integral of cosine, which is going to be sine. So this is going to be 1/3 of sine of 3x. And so at the end, this is going to be minus x squared over 3 cosine of 3x plus 2/3. And then now we reflect what this integral is in terms of this u times b, and so x over 3 sine of 3x minus the integral of b du, and so that will be 1/3 sine of 3x dx. Now notice that this integral here is easy to actually solve. So that was the last part. This is the last part that we'll need to address. The integral of sine, of course, is cosine. It's minus cosine, and so this is going to give me a plus here. This here becomes 2 over 9 x sine of 3x, and this 2 over 3 with this 1 over 3 becomes plus 2 over 9, and then the integral of sine, remember, is minus cosine. That's why minus with minus becomes a plus, and then we give another 1 over 3 cosine of 3x. And so this needs a plus c here, and that'll be the end of this first integral. So as you can see, when you're doing integration by parts, you might need to do more than once parts in the same integral. Doing just parts once is not necessarily going to give you right away the end results that you want. Now let's go to integral 2, which is e to the x sine to the 3x. Now this has an issue compared with the previous one, and is that you notice that in here we were reducing the power, and when we're reducing the power, then we get to a point where at the end we're not gonna have a power and we're done. But the problem with this e to the x sine of 3x is that that's never going to happen, because we cannot reduce e to the x. So in here that's not going to occur. So what's going to happen with this is that we're going to have some sort of iteration formula come into play. So for example, we're gonna go with, let's do parts u equals e to the x, and so du is e to the x, dv is gonna be sine of 3x, and so of course b is gonna be minus 1 over 3 cosine of 3x. And so of course this integral here transform into u times b, so minus e to the x over 3 cosine of 3x, that's u times b, minus the integral of b du. But b du is just again e to the x cosine of 3x dx. So we're just traded here the sine by the cosine. We did some of this, we did this example in the past on some of the video examples, but here we'll have back this situation again. So now what's going to happen is that we're gonna need to do again parts with this, okay? And so if we're doing parts in there, notice that we have for this one, we have that u is equals e to the x. We follow the same pattern. The u is e to the x, dv is going to be cosine of 3x, and so that means that when I integrate and I find what b is, this is going to be 1 over 3 sine of 3x, okay? And then the product of that is going to be that this is going to be e minus e to the x cosine of 3x, and I'm going to have this 1 over 3 multiplying here. But let's see what this will give me. This will be u times b will be e to the x e to the x over 3 sine of 3x. That will be the u times b. And now minus the integral of b du. But b du will be 1/3 of the integral of e to the x sine of 3x. And so as you can see, we have the same integral that we started with here. And so what's going to happen is that I'm going to move this to the other side. Notice that if I multiply this 1/3 by this 1/3 here, I'm going to have minus 1 over 9. So I'm going to have minus 1 over 9 to the other side, and this is going to give me 1 plus 1 over 9 integral of e to the x sine of 3x to be equals to, and then we have this part over here, so it will be minus e to the x over 3 cosine of 3x plus, and then this piece here is a reminder, 1 over 9 e to the x sine of 3x. Okay? And so we remember that this part is being added to this side because this is an equality. This is equals to this and equals to this. So we can move this piece to the other side, and that's where we get this. So at the end of the day, we get that e to the x sine of 3x, the integral of that is going to be this part, which is going to be minus e to the x over 3 cosine of 3x plus 1 over 9 e to the x sine of 3x. And then I'm going to divide now by the sum of this number. This is 9 over 9 plus 1 is 9, it's 10 over 9. So I divide by 10 over 9 here. And so that's pretty much the end of what this is going to be. Of course, we add the integration constant, and then we can flip around this and multiply the top as 9 over 10. All right, so now we're going to go for question 3. We have the integral of arctangent of 2x dx. So because we don't know the antiderivative of arctangent, we're going to use parts to be able to obtain an integral that is different and that we can manage to do something else with that. So if you use arctangent of 2x, then the dv can be thought as being the x, and so that means that b is just going to be the integral of the x, which is x, and du, the derivative of arctangent, is going to be 1 over 1 plus 2x squared. And of course, because we have the chain rule here, then we multiply by the derivative of 2 and 2 dx. So that'll be 2 dx here. So now we apply u times b. And so this will be x arctangent of 2x minus the integral of x b du, which would be 1 over 4x squared times 2 dx. So now this is a much more easier integral to manage, and you can see that very likely we're going to be able to use a substitution rule. Notice on the top we can have this, we can even pull out the 2 here, and we're going to have x 1 plus 4x squared dx. So if we're thinking for substitution for this one, the clear candidate is 1 plus 4x squared, and so the du will be 8x. And so replacing that, we get that this is x arctangent of 2x minus twice, and then this is going to be replaced by u. And of course, from this, the dx can be replaced by du over 8x. And so du over 8x and this x here, they're going to cancel the x, which tells me that things are okay. And so this is x arctangent of 2x minus twice, or 2 over 8, integral 1 over u du. And this is a log. And then I can go back to the original variable here. So x arctangent of 2x minus 1 over 4 log of u. Remember, u is 1 plus 4x squared. So I get to do that, and then plus c. And so that's the end of that integral. So now for question 4, I have the integral between cosine to the 5 and sine to the 4, the multiplication of those. And so for the integration of this, it's not going to be easy to do by parts, so I'm going to use a trigonometric integral strategy. And so what I'm going to do is, well, it would be nice if I can do substitution. So for example, if I could do u equals sine, then the du will be cosine, right? And so to be able to use that substitution that I want, remember I want u to be sine of x, and so du will be cosine of x. So I want to get this du, and so if I want to get that du, I'm going to pull one of this cosine, and so I'm going to leave cosine to the 4 of x, sine to the 4 of x, and I'm going to pull that extra cosine here, cosine of x dx. So at this point, I can probably have the du, and this will be u to the 4. The problem is this cosine to the 4th. But cosine to the 4, I can see as cosine square is square. And cosine square is also, in terms of the signs, 1 plus sine square. So this is like 1 plus sine square square. So I can see this as 1 plus sine square square times sine to the 4 of x times cosine of x dx. And so now this will be du, this will be u to the 4th, and this will be u 1 plus u square square. And so that's going to be my new integral. And now I can open this up to be able to integrate. So breaking this binomial, this is the first square plus 2 times the first one by the second plus the second square. And then multiply by u to the 4th. And that's going to be u to the 4 plus 2u to the 6 plus u to the 8. And that way integrate the powers. This is u to the 5 over 5 plus 2u to the 7 over 7 plus u to the 9 over 9 plus c. And then at this point, I can go back to the original variable. So this is 1/5 of sine to the 5 of x plus 2 over 7 sine to the 7 of x plus 1 over 9 sine to the 9 of x plus c. And that's the end of this trigonometric integral. All right, now integrals 5 is secant to the 4 tangent to the 5 x dx. And there are multiple ways to approach this, but one of them will be making the substitution u equals tangent. Notice that if we do that, then the du will be secant square. So we can kind of arrange this so we can have what we want. So if we're going to get a secant square, the x, then we need to remove secant square from here and put it next to the dx. So the secant to the 4 becomes secant square, and the secant square here. Okay. Now that I have this, then u is equals tangent of x, and remember that secant square has an identity that relates this with tangent, which is tangent square plus 1. So pretty much I can transform this into tangent square plus 1 times tangent to the 5 times secant square of x dx. And you can see here that if I replace by u du, then this becomes u squared plus 1 u to the 5, and this transforms into the du. Now that's going to transform the integral into u to the 7 plus u to the 5 du. And this is going to be u to the 8 over 8 when I integrate, plus u to the 6 over 6 plus c. And then going back to the original, this is tangent to the 8 over 8 when we replace for the original variable, tangent over 6 over 6, and that's it. You can also do this one by using the secant, but the arrangement and the way that you gotta play with the variables is different. So if you want to check how to do that one, check the solutions that are written that you'll find in the module. There you're gonna find out the other option as well. But now I'm gonna proceed with 6. And so in here I want to do kind of like the same thing, but I have a more overpowering secant. I have secant to the 7, so I would like to have u to be secant. And then notice that if a u is secant, then the du is going to be secant by tangent dx. And so what's going to happen is that I can just take one of each of the elements here. So I'm going to have tangent square secant to the 6, and I'm going to have secant by tangent of x dx. So I remove one of this from each of them to have them be the du. Now tangent square can be related in terms of secant. Remember that tangent square is just secant square minus 1. And so I can put that in here, so everything is going to be in terms now of my u. And so when I transform the integral, this is just going to be u squared minus 1, u to the 6 du, or u to the 8 minus u to the 6 du in the integration. When I integrate, this is u to the 9 over 9, and then minus u to the 7 over 7 plus c. And then I can just replace back to the original variable. That will be secant to the 9 over 9 minus secant to the 7 over 7 plus c. Okay. Now, if I have this tangent cube of x, I can kind of follow with the same arrangement. So I can see u being maybe tangent, right? But if I have that, then the u is going to be secant squared. So I better transform this somehow. And so I can see this as tangent of x times tangent square of x dx. And remember that tangent has a relationship with secant. So tangent square is secant square minus 1. And so I can transform that here. And so this is going to transform the integral to tangent of x secant square. And I'm going to have one integral there. And then I'm going to have the integral of tangent of x dx. And both of these integrals are things that I know. So of course, because I'm going to be doing u du, right? Then this is just going to be u squared over 2. And for this one, if you remember from before, tangent is sine over cosine. So I can just make this the log of cosine at the end. So this, for an integral that we previously saw, this is just going to be the log of cosine of x. And u from this here will be tangent, so 1/2 tangent square of x plus log of cosine of x. If you don't remember these integrals, we saw them before in the video, so make sure to check those out to see how you actually get to do that substitution. Okay. Last but not least, we have the integral of cosine of 2x times sine of 3x. And this is a multiplication of two different trigonometric functions with two different angles. And so we can use the product identity. So if you remember the product identity, we have sine of A cosine of B, the multiplication of those being 1/2 of sine of the difference plus sine of the sum. So we can kind of combine this. And so applying that and making this, let's say B, and this one A, right? Then that's going to be transferred to 1/2 of the integral of sine of 3x minus 2x plus sine of 3x plus 2x. And then of course I can simplify this. This is 1/2 the integral of sine of x dx plus 1/2 of the integral of sine of phi x dx. And so I simplify this integral of a multiplication into the sum of two different integrals. And those are going to be much more easier to manage. The integral of sine is minus cosine, so minus 1/2 cosine of x plus, and then 1/2. And so the integral of sine, again, is minus cosine, but because it has a 5, then it produces an minus 1/5 cosine of phi x. Okay, and so that's the end of the questions on the week 2.